why not start validating? You mentioned apples, so
Mm-hmm.
key to my heart. Why not start validating in Nova Scotia? Why not start there before approaching the Grow New York region?
Yeah, good question. And when we enter a new crop, we look to enter it with a research partner. This is key to not just getting the data needed to calibrate, but to understand the exact things, what nutrients do they want to see, how the agronomists are using tissue tests. We have done a project in Quebec this year with some apple growers and heard from multiple apple growers that they're interested in this. But really the key that's missing is that research partner in Cornell Agritech. And they have apples within greenhouses, which is very rare. So for us being able to calibrate over the winter and then by summer do a more extensive project, that's really been the limiting factor.
Okay, interesting. Collaboration is very important. Mm-hmm. Question for I'm going to pose this to you as well. Question for your team. Where do you think you're missing?
Yeah, like definitely being 4 engineers, I think we're great on the technical side. We love data, we love AI, we love building things. Going forward, I think getting especially a sales team established, a professional sales team, taking what we've learned and extending it is the #1 priority, as well as being able to scale manufacturing. So having a service center. Right now we have a small office out in Eastern Canada, but having a full facility close to where our optics are manufactured would be key to going forward, scaling to hundreds or thousands of units.
Okay, thank you.
Thank you, Carrie.
Damien?
Thanks for the presentation. You kind of talked a little bit about what you are going to do with the prize money, but could you be a little bit more specific about what you want to do long term, especially for Grow New York?
Yeah, good question, Damien. For the prize money, there's 3 key things we want to do immediately, which is 1, work with Cornell Agritech to extend this to all the growers, build the calibration in new crops, and basically get adoption throughout the state. Second is that sales team piece, and then third would be the manufacturing. Long term, we see this as our base across all the US, that we can service the Midwest as well as the East Coast, and kind of grow from there. Yeah.
Okay, thank you.
Thank you.
Anthony?
You seem pretty well versed in AI technology.
Mm-hmm.
Can you elaborate a little bit beyond AI specifically? What types of AI are you leveraging? Generative AI, OCR?
Mm-hmm.
Talk a little bit about the magic, please.
Yeah, absolutely. So we started this project in 2020 looking at, could we match the structure of the leaf with the chemical composition? So with that, we've built our own AI models and our own data sets to be able to look at the scan, look at the chemical results, match those up and run kind of AI to do pattern matching. So when we show it a leaf, that's a corn leaf at this stage that has a calcium deficiency, it knows that, oh, well, these wavelengths are more pronounced, that means you have thicker cell walls, that means you have more calcium. So it's all custom built. We own the IP and the models. We have leveraged Gen AI in things like automatic label matching, making the process easier, but most of it's kind of our own neural nets that we built from scratch.
Glad you mentioned that piece of it. So how do you give an end user confidence that we're accurate if we're giving them information to actually make a decision?
Yeah, absolutely. And that's one of the first questions folks ask. And I actually have one of the slides here showing one of the reports we've done, showing that we can be much more consistent than even lab results. Doing 250 samples from potato fields we sent to the lab. The lab was, as you can see with some of these macronutrients, 10 to 20% difference on average with itself. This is both due to degradation during shipping as well as experimental error, while our method of sampling fresh leaves had lower than 5% variance on average. So as we can never match exactly every lab sample, we're focused on making a useful, consistent standard that growers can trust. And this goes within every sale we do. We include a validation budget that we can actually send samples to the lab and check. This helps us continuously validate and build better and better models, and it helps build trust with our agronomists that we can give good results.
So with the SaaS model, obviously data is key, right? Yeah. So you're building a data moat for yourselves, but who owns the data? How do you have that conversation with data ownership and security for farmers?
Yeah, and that's a key piece, right? If you talk to a farmer, they want to own the data, and then with our system, they own the data point. So if we do the scan and do the lab results, they own the data point. We get to use anonymized statistics to retrain our models because that's the core technology, but they own the actual sample.
Thank you.
Thank you.
Mary.
So it's intriguing, but kind of thinking through it as a farmer, I'm wondering how actionable this actually is,
Yes.
especially on broad acres, because so my farm in Kentucky, 275 acres of corn one year, soybeans the next. But if I go out and do samples, at some time, like, what am I actually going to do with that? You know, if I find out, and the land's very variable, so maybe this area is one thing, this area is something else, but I can't just run out and do this and fix that. So walk me through that, and then I have a follow-up for you.
Yeah, absolutely. And that's why we work with ag retailers. We work with crop consultants and agronomists, because they're already doing the legwork of zoning out the land. So it's a representative area, and they already have the trucks, the scout to go and visit the field. What we're doing is, instead of going to visually inspect it, they can actually turn every visit into a tissue test. That gives them way more context and goes from spending their time diagnosticking, what's this issue with this side of the field, to then making a plan with the farmer to give the recommendation. So that's why it's important to have the agronomist in the loop, so they can go kind of jump to action.
But even with that, though, I mean, you can't necessarily go out and just like dose that part. But let's leave that for a second. I'm still boring you about it. Competition. There are other kind of in-field scanners here. What makes you different from what else is out there today?
Yeah, absolutely, Mary. Like, there's two main differences. The first is that within our system, as you can see, it's a bit bigger, it's a bit heavier, it's a bit more expensive for us to make. The reason is because we invest a lot into the optics themselves, which is most of the cost of the system, so that we can actually get more broader band and more resolution. So as we're growing this network, both with clients and universities, we get the best data set. So we're more confident on our models on that side. The second, like I mentioned, we have spent a lot of times on actually the platform to bring in context. So it's not just giving you a table or a PDF with results. You see the sample locations throughout the season on the platform. Geospatially, can look at the benchmarks from previous years to then, what are the best performing fields? How did they act? Let's try to recreate that. As well as having custom critical levels, like I said, from the local research institutions. So it's taking the step beyond and not just giving, numbers, but giving, is this good for this region, for this crop? Yeah. Thank you.
Good, Mary? John?
Great concept. How do you see your product in light of, I think in the last few years, there's been a rise in a number of apps you can readily get on the phone that can diagnose plants just on a picture. I don't see a very far stretch from someone doing that on a houseplant level to a farm level. So how do you relate your product to those products?
Mm-hmm. So with a picture, you can basically do what you can do with visual analysis. So you can look for, like I said, colorosis. You can look for, tinging of the edges. If you have, will turn purple if you're really deficient in potassium. By that point, it's already too late to recover most of the yield, is the issue. So by building this system that can see within the texture of the leaf, we can detect way earlier exact nutrient concentrations, which you can't do with just a visual image. Same with like satellites or drones. You can get a good representative area, see how big the plants are, how green they are, but you still can't get that chemical composition that directly ties into which nutrients you need to apply.
Great answer.
Okay, thank you, John.
Ben?
Thanks. So you talk a lot about kind of for the hyper-regional or the hyper-local farmer, the insights they get. Does that also scale? So as you get more adoption in a region, do you have regional insights that those farmers are getting? Like, what is the benefit? Is there a flywheel of benefit as you kind of scale the system?
Absolutely. I think the more we dig into this, the more we realize that, for all of corn in the country, there's basically one recommendation when you send the sample off to the lab, which is built off like greenhouse work 30, 40 years ago. We know that crops are much more specific than that, especially when you get into like horticulture crops. You might only get one recommendation level for the whole crop's life. That's not how things really work. So as we get more and more data, get more into it, know which fields perform best and to what nutrient trends go into that, we're hoping to advance agronomy in that area. So by having the researchers involved, that helps us act on that and put it back into the platform. But even the commercial clients, a lot of them have their own research farms that are then using this to convey those insights to growers with their own critical levels. So yes, absolutely, that's a big part of it.
Okay, I'm going to have to call it there.
Super.
Thank you so much, Paquetta Systems.
Yeah.
Good job.